Hey guys, Major Matt Voke. Today we're going to be talking about blockchain. I've gotten a lot of requests specifically from you guys about what blockchain is, mostly what blockchain isn't, what it's capable of. We're going to go over that in 10 to 15 minutes. You'll inevitably have more questions than you have answers delivered here. So feel free to email me, matthew.voke@socom.mil. Or what you should do as well is look up NIST 8202, which is what I use to frame the bones of this briefing. What is the problem? Why are we here? Why are we discussing blockchain? The problem is data and data assurance and data immutability. If we see up on the top right, data coming into a server and then being put out to multiple other servers, or in this case, the World Wide Web, we need the ability either by a person interpreting that data and making decisions on that information or data, or machine learning and artificial intelligence in determining if that data was either poisoned, compromised, adjusted, or anything. So blockchain provides the ability to at least see if that has happened. We need to also be able to tell in some situations where the data is coming from, and then if the person providing that data is saying different things to different parties. In this instance, the Byzantine general's problem of attack the city to one lieutenant and retreat to the other lieutenant, causing chaos in the ranks. What we're going to talk about today, again in about 10-12 minutes, is blockchain basics. We're going to talk about hashing because it's heavily important in blockchain. We'll talk about both public and private blockchains, how they're different. We'll talk about some asymmetric key cryptography, very, very briefly, no math, I promise. We'll talk about consensus mechanisms and how they are interpreted and implemented in blockchain. We'll talk about two use case examples of smart money and smart contracts. And then we'll conclude with some takeaways for this. Blockchains are distributed ledgers or distributed databases, meaning if I take down one computer or node, I'm not going to eliminate that ledger from existence. I have backups. They are tamper evident, and because of that, they're also tamper resistant. If I know somebody's going to be able to see me screwing with this data, I'm less likely to do so. They are trustless, meaning that you don't have to trust necessarily the counterparty that you're either giving money or taking some assets from. And you don't need a trusted third-party intermediary, such as a bank or somebody. If you were selling a house, for instance, you could sell a house on the blockchain without needing a title company or anybody else in between the two parties. Data protection through cryptography. So if you want to think about blockchain as a cryptographic securing of a trustless, tamper-evident distributed database or ledger is the basics of what blockchain is. The basic blockchain is the foundation of cryptocurrencies, and you guys have probably heard about Bitcoin. There's many other cryptocurrencies, but that is just one use case of blockchain. We'll talk about some others today as well. Public and private are basically the two variants of blockchain, but you also have public and private keys used to encrypt and to sign things in blockchain technology. And then you probably will hear about mining as well. Mining is the way to secure the blockchain by getting those that have their version of the truth actually writing that to the blockchain. They're securing the network. Blockchain is basically a chain of blocks. You see on the bottom, you have a number for that, usually a timestamp, a number that only occurs once, a nonce, and then you have data. And you're going to hash that. And that is going to be essentially your securing of that block and adding it to the blockchain. Once you do that, it is going to be added to the blockchain and other miners are going to build on top of that. So in this case, the reason it's called a chain is because each block is cryptographically tied to the previous blocks. And if you adjust something in the past, every subsequent block will be evident that that was tampered with. You've heard me mention hash functions. So hashing is essentially creating a fingerprint of data. Anything that can have a binary representation of ones and zeros, if you want to think about it like a text file or a picture, for instance, can be hashed and created a digital fingerprint so that you're sure that that file or fingerprint is that file or fingerprint and it hasn't been adjusted, even 1 pixel. So for every input you put into a hashing function, you're going to get a unique output. And every single time you put that input into the hashing function, no matter on what computer, you're going to achieve the same fingerprint or output or hash as how it's phrased. That is going to be usually a fixed size. So for SHA-256, that is going to be 256-bit output. Down at the bottom, you can see both the 1 being hashed, the 2 being hashed, and each individual one of those is going to have a separate fingerprint or hash, and they're going to look completely different and foreign to us. What's important is that it is repeatable and that you don't have what are called collisions, meaning two separate inputs achieve the same output or hash. That would be bad. Here are a couple of use case examples of blockchain. I already talked about a couple of them. Smart money being Bitcoin in this case, or cryptocurrencies. Smart contracts being an agreement that is legally enforceable on data or code. Distributed ledgers between companies, if you want to think about a consortium of banks or other entities getting together and agreeing on who owes whom money or agreeing to some version of the truth. Supply chain management. In Walmart, for instance, is handling their handling of lettuce and the actual supply chain management of it, from the actual growth to the actual delivery to the customers, and the ability to instantaneously establish what batch is bad and trace that back to where. It significantly limits the amount of recalls and the speed in which that can occur. Public records, if you want to think about a title company or a government having records that are on the blockchain, immutable, not being able to be changed unless you intentionally do that and mean to transfer land use, for instance. And then identity management. Every single time I go to the store to buy a case of beer, I don't need to provide them my address. I don't need to provide them anything other than the year I am born, yet we provide and hand over very easily and readily data that we should hold sacred. So what's the difference between public and private blockchain? I mentioned it already. Permissioned or private blockchains are just that. You're authorizing somebody to write to that network. You can authorize whomever you want to read from that network, but ultimately you're authorizing specific individuals or organizations to change truth on that network. Whereas permissionless or public blockchains, you're looking at anybody that has resources, effort, will, can write to that network. There are strengths and weaknesses to both of those. One approach to leverage the strength and mitigate some of the weaknesses on both of those is what's called the hybrid blockchain, using a private or permissioned blockchain to do a lot of the heavy lifting and make it faster, and then writing updates to truth data to public blockchains, which leverages a lot of the strengths of both of those. Asymmetric key cryptography is used pretty heavy in here, and I'm not going to go too much into it because it is in the weeds. But you're basically using a public-private key pairing to mathematically link a message and be able to encrypt and decrypt and to sign that message. If my public key is out there on the internet, you can encrypt your message with that, and I will be able to decrypt it using my private key, for instance. That enables me to tell you are you, or you can tell I am me, because those are linked to each other. Don't let your keys get stolen. That's hugely important, especially when you're talking about having money being on those keys, essentially. Determining consensus is the way that we tell in the blockchain who can write to the network, whose version of truth is truth. In private networks, that is done with authorities. In public networks, that is done in a couple different ways. But it's basically whoever is invested the most in the network usually has incentives for that network to survive and thrive. So proof of work is basically you doing a lot of work, owning a lot of hardware, a lot of electricity to write truth data. You have incentives for that network to continue. Proof of stake, meaning you're going to stake a decent chunk of money on that network so that you can write that truth. And if that action that you have writing on the network is nefarious, that stake gets slashed or taken away from you. Those are two examples. We just talked a little bit about proof of work, but proof of work is basically you guessing thousands, millions, or billions of times per second at the nonce, the number that only occurs once in that block, so that when you hash it, you achieve a specific required difficulty. In this case, it's represented as the leading zeros. So in this case, we have several zeros before the echo, Charlie, and then so on. So I'm going to guess billions of time at that nonce, so that every time I hash it, I'm going to see whether that hash is under that threshold. And then I get to write my version of truth to the blockchain. The other miners are going to see that new block and then work off of that block, and it's just going to continue that blockchain. The most popular implementation right now of blockchain is smart money is, like you guys have probably heard, Bitcoin. That is not the only one, and that is not the fastest growing use case either. The reason that Bitcoin succeeded for the last 10 years is that it has all the important properties, some better than gold, some not as good as gold, but most better than fiat currency, of divisibility. I can divide that very easily. Fungibility, meaning one Bitcoin is worth one Bitcoin, $1 is worth $1. And whenever I go to exchange it for somebody, it's portable. I could memorize a 12-word seed phrase in my head and transfer that money across a border, for instance, and not get seized. It is durable. As long as I remember those 12 words, for instance, nothing's going to happen to that unless I get killed, for instance, or if somebody does destroy those keys, that's the only case that it will not propagate. It's a medium of exchange, meaning that I can use it, and that's not so strong now, but there's a lot of people working on that, and then it does have a limited supply, meaning that is deflationary. Smart contracts, we talked about a little bit, but is me entering in, based on data and code, an agreement with some other organization or party of what will happen. The benefit of these is that they can occur autonomously and without that third-party intermediary, which has huge efficiency gains and potentially streamlines that can occur based on that. It minimizes the need for trust, but doesn't fully eliminate it. Here's what I want you guys to take away from this. And again, email me if you guys want to go a little bit deeper into this. But blockchains are distributed ledgers with the ability to make data transparent, secure, immutable, tamper-resistant. You can create trust or mimic trust in situations where there is no trust between the organizations or parties. They might not even be known to each other. They are extremely inefficient databases, especially the public blockchains. So these benefits to immutability, tamper resistance, uncensorable, etc., must be significantly outweighing the cost of actually running these. Usually today, it's actually in a significant amount of electricity being burned. Public versus private blockchains have significantly different characteristics based on what you're trying to do with them. Choose wisely. And then blockchains, lastly, is not a destination. Don't seek out the implementation of blockchain just because you want some blockchain. Actually use it as a tool to get somewhere novel, somewhere new, a new paradigm. Again, Matt Voke, if you guys have any questions, shoot me an email. Appreciate your time. Thanks.